Okay, let's throw another curveball your way. When it comes to aeronautical travel, aeronautical, what does that mean? Planes in the sky. Okay, when you're flying in the air, there is no such thing as the x-axis. Like if you're talking about something that's on the ground, right? Then you can measure from the ground up. Then it would make sense to talk about standard position of an angle. Okay, so it gets a little bit complicated when you're talking about aeronautical travel. So when a plane is in motion, its angle of direction, its direction, I don't want to call it its direction angle just yet, but its angle of motion is measured from due north, which is labeled as 0 degrees. So this is where things can get a little weird, okay? When you're talking about problems that involve planes, and we're about to do that, okay? Specifically with velocity vectors of planes. Due north, straight north, this is 0 degrees. Okay, and I'm do my best to make this as simple as possible. Then angles are measured clockwise from there. So this would be 90 degrees, this would be 180 degrees, and this would be 270 degrees. This system only applies to problems involving airplanes right now for what we're doing. Okay. I don't think we're going to do any boat current problems, but you may also, you'd have a different system of bearings to measure from that. We're just going to try to keep this as simple and only go with one. Okay, so for example, a couple of examples here to give you an idea. If a plane is traveling, let's say traveling in this direction. Okay, so we could label that angle a whole bunch of ways, right? Based on what we've talked about so far. But if it's an airplane traveling in this direction, we would measure from due north down to here. So we would say that, and I tried to get it as close as possible, we would say that that's 135 degrees. Okay, so it's just one of those quirks about problems that involve airplanes. If you're measuring the direction of an airplane, 0 degrees is due north, and you're measuring the angle clockwise, not negative 135 degrees, 135 degrees. What I think makes sense for us, okay, because we've been so used to measuring these angles in standard position, we need to figure out what this is in standard position. Okay, so from standard position, the angle that we're talking about here would go like this, right? To keep things consistent. If we were talking about a vector going like this, the standard position of that angle would be measured like so. And I think for the sake of consistency, we should keep it that way for all of the calculations that we're going to be doing. So, there's some conversions involved in these problems. There's an extra layer of math involved to set these problems up. And you'll see what I mean once we do our first problem. But if this is 135 degrees, if this right here is 135, and this piece right here is 90 degrees, that means this piece has to be 135 minus 90, so that piece is 45 degrees. So we have from here 90 degrees and then another 45 degrees in this direction. We would have called that negative 45 degrees in standard position, right? So what are we talking about as the direction angle of this from here? We're still talking about that angle that's almost making a complete 360, but we're 45 degrees short. So we take 360 and subtract 45 and get 315 degrees. So this is the number, this is the direction angle that we would use for this vector in standard position. Okay, let's do another one. One more, hopefully. Let's go here. with this vector. I'm gonna erase this other work if that's okay, just because I don't wanna overcomplicate things. And we'll get rid of this guy. Complicate things more than normal, I suppose, right? So if this was an airplane traveling in this direction, let's adjust it. Let's move this so that it's here. This angle would be from here, 90, 180, 270, and then I'm going to give it another 30 degrees. So I'm going to say this is a bearing of 300 degrees. All right, consider a bearing, right? Bearings. From 0, measured clockwise, 90, 180, 270, and then another 30 degrees. This is 300 degrees, a bearing of 300 degrees. So if that's true, and again, if all the way over to here is 300, and from here to here is 270, that means this reference angle is 30 degrees. That's not the direction angle of the vector though, right? The direction angle of the vector is measured from here over to here. So just this. All right, so this is that extra layer of the problem that we're talking about. If the bearing goes this way and the standard position angle goes this way, and this is 30 degrees, this angle is 30 degrees shy of 180. From here to all the way over would be 180. We stopped 30 degrees short. So the direction angle of this vector would be 150 degrees. So they give us the bearing. We're responsible for, before we really do anything, after we draw the picture, but before we really do anything, we should find what the actual direction angle of the vector is. Okay? So I realize that this complicates things a little bit. It just adds another layer involving bearings. But if we're going to talk about real world applications of this stuff, this is how the direction of a plane is measured. So we should do our diligence with that.